All right, so the problem I picked was to prove the Pythagorean theorem. So I went to one of my coworkers for a little help on this one, see if she knew of any proofs before I started researching stuff, because she's very much into math just like me, and she teaches the Pythagorean theorem to kids. So what she told me to do was just to use a square, and after she explained it to me, it's a little bit more challenging than I don't know. It took my brain a minute to kind of wrap my head around the whole idea, but once I figure it out, it's actually really cool. So the way that she explained it was kind of just to make two squares and two rectangles off to the side here. So I'm making, the two squares are folded over. So here's my big square and my little square. All right. So then let's just say that this segment is A, which means because if it's a square, then this is A. So then this one can be B, and because it's a square, this line segment is also B. All right. So then A times A is A squared. So the area of this whole thing is A squared, right? And then this square, B times B, would be B squared. This whole area being B squared. So then when you think about the Pythagorean theorem, we know that it has to do with the right triangle. So then I can make a right triangle right here in my picture with this segment being C, right? So I'm trying to prove A squared plus B squared equals C squared. So I've got my A squared here, and I've got my B squared here. And then if I fold along my hypotenuse, right? If I fold along here, I already said that this segment is C. So this segment is also C. And this, and this, and this. So then if I open it back up, I can see that the original triangle that I made, and then this triangle, I have two different triangles. And then I have two triangles over here that are the same area as my two triangles that I started off with. So that's my third and my fourth triangle. Okay. If I flip it over, I have that C segment that I had from the other side, right? From one of my triangles. So my C segment, exactly the same length, just on the other side. So then because I folded it over, this side, this segment is C. This segment is C. And this one right here would also be C, right? So then C squared plus C squared, or C times C is C squared. So here are my four triangles, right, that I had on my opposite side. 1, 2, 3, 4. And I have four triangles on this side. So then the triangles on both sides cancel each other out, and I get this area, A squared, plus this area, B squared,